So today we are talking about arcs and central angles, and I'm going to do this in two parts, two different videos. So the beginning is just going to be the notes and talking through exactly what all the definitions mean, and then we're going to do another video that has the examples on it. So when we think of this word central, then most of us go to the word center. Okay, so when we have central angles, they are going to be at the center. Okay, now the other thing we've got is when we're talking about arcs, and arcs are going to be on the circle, okay, or on the outside edge of the circle. Okay, and we're going to see the relationship between the two pieces, between the arc and between the central angle in just a minute. Okay, so as we look here, okay, we see that we have an angle with its vertex at the center of a circle, and that's going to be what we call your central angle. Okay, so when we look here at your picture, we have point Q in the center. We have point A, X, B, and Y on the outside. So all of our central angles have to have point Q as the center point. Now remember, we name a central angle with 3 letters. So one of our central angles could be this angle right there, which we would call angle AQX. Now you can continue in this similar fashion as you go around the circle. So the next one that we would have would be angle XQB. That would be this angle. Okay, then we could have angle BQY. Then we could have, that would be this angle. Okay, then we have angle YQA. And those are our 4 most visible angles. This would be that last one that we're talking about. Now, there's one more that we have here, which would be from A to Q to B, which would also be considered a central angle because the vertex is B. Okay, so those are your central angles in the center of our circle. Now, as we move on and we're talking about this next piece, we have arcs. And our arcs are the unbroken part of the circle. Okay, so when we're looking at an arc, we classify arcs in 3 different ways. Okay, we're going to have minor arcs, we're going to have major arcs, and we're going to have semicircles. Okay, and our first one that we want to look at is this minor arc. Okay, now when you think of minor, we're probably thinking of smaller. Okay, so the most important thing here is that we have an arc with a measurement less than 180 degrees. That's the most important part. Okay, so as we look at our picture here, we're thinking, okay, I've got an arc, it's got to be less than 180. So one of your arcs, okay, one of your minor arcs could be from A to X because that is a part of the circle. Okay, when we write an arc, we're going to say AX with an arc over the top of it. Now, here's the thing about the arcs and their angles. If I say that arc AX is 50 degrees, okay, then that measure is equal to its central angle. Okay, that's equal to its central angle. So if that arc is 50, then the angle that's in between that arc would also be 50 degrees. Okay, now we do name our minor arcs with 2 letters, so we've got AX. Okay, let's give some other examples. We've got XB. We could have B to Y. We could have Y to A. And we could have A to B. So those are all types of minor arcs. Okay, so continuing on, the next one we have is major arc. And in a major arc, we have an angle that is an arc that is greater than 180. The measurement is greater than 180. Okay, the measure is still going to be equal to that central angle, just like on a minor arc. Oops, let me change colors. Central angle. But now we're naming this arc with 3 letters instead of just 2 letters. Okay? So when we look at major arc, we know that our major arc has to be more than 180. Okay, we talked about 180 going along our diameter a couple of days ago. Okay, so if this is my diameter, then when we have a major arc, we have to go past it. Okay, so I'm going to start at X, and if I go all the way to Y, that's 180. But then we got to keep going to get past 180. Okay, so we're going to say that one of our major arcs is X, Y, B. Now, I like to name my major arcs with the ends of the diameter. So this was X, this was Y. Oh, not B. Sorry, guys. Okay, we don't have B here. We have X, we have Y, and we have A at that pink highlighted area. Okay, I like to go from my diameter point to my other diameter point and then go past it, which is why I said X, Y, A. Okay, so let's look at another example. Okay, now we can't go that same direction again and get anything else, but we could start at Y and go Y to X, which is like 180, and then go past it, and we would end at A. So that arc we would call Y, X, and we ended at A. So the order of your letters here is super important. Okay? Now, you could have some other ones. Okay, I'm just going to give you one more example. You could start not on the diameter, like here. Okay, and we could go from BYA, and you clearly see that that's more than 180 degrees, so we could have arc BYA. Major arcs tend to be the hardest ones, so just make sure that you're being careful. Okay, the next one and the last type of arc that we have is a semicircle. Okay, semicircle, and most of you are pretty familiar with this. Okay, your semicircle has a measurement equal to 180, okay, or of 180, and its endpoints are on the diameter, okay, which is kind of what I was just talking about. Our diameter is X to Y. Okay, and we don't have any other diameter on this picture. That's the only one. Okay, so our examples, my thing got cut off, but let's write some examples here. We have to be on one side of the diameter and then the other side. So the top semicircle would be this one. Now you see we are naming, again, with 3 letters, just like we did for major arc. So you could name this going from X, A to Y, or you could name this going backwards from Y, A to X. Either way works. Okay, so X, A, Y, or Y, A, X. And then your other semicircle that we have is going to go this direction from endpoint to endpoint on that diameter. And so here we have XBY, okay, or you could have YBX. Either way would work. Okay, so YBX is the same thing as XBY. Either one would work. Okay? So, moving forward, we've got a couple of other things that we want to look at here, just definition-wise. Here it says arcs with exactly 1 point in common. We're going to call these adjacent arcs. Remember that adjacent just means next to. Okay, so if we're looking at this picture, we know that they have to have 1 point in common. So we have a couple of different pairs that we could have here. Okay, we would have arc IJ and arc JK would be adjacent arcs. Okay, we could have arc JK and arc KI because the K is shared. And we could have KI and IJ because our I is the shared point. Okay, so adjacent arcs are just going to pop up from time to time. Okay, now the next thing has to do with arc addition postulate. We talked about this when we did angle addition. We talked about this when we did segment addition. It's pretty much the same thing. Okay, so it says the measure of the arc formed by two adjacent arcs is the sum of the measure of these two arcs. Remember, sum means we're adding. So here we've got AB, which we knew was 70 right here. Okay, then we know that if that arc is 70, this angle has to be 70. Then we knew that this angle was 80 right here. So this arc also had to be 80. So when we add 70 plus 80, like I did right here, then we ended up with 150. Okay, we know 150 is less than 180, which makes it a minor arc, which means we're going to name our arc with two letters, the beginning letter and the ending letter. So this would equal the measure of arc AC. Okay. Then we've got these arcs that are in the same circle or congruent circles that have equal measures. Here you see that all of these arcs have 90 degrees involved in the angles, so they would all be 90 degrees. And we just call these congruent arcs. I think that's pretty self-explanatory. Okay, it's just, that's how it is. Okay, the last thing I want to talk about is Theorem 9-3, as they call it. Okay, it says in the same circle or in congruent circles, two minor arcs are congruent if and only if their central angles are congruent. So I drew in this picture, and you'll see that we put angle 1 is 40 and angle 2 is 40. So if angle 1 was 40, then we knew that the arc also had to be 40. And if we know angle 2 is 40, then we know that this arc has to be 40, making those arcs congruent. Okay, now we found this 100 right here by saying, well, we know that the half of the circle is 180 minus 40, which gave us this 100. Okay, so central angles and their arcs are equal no matter what. Okay? And that's where we're going to end this video. So if you need some more examples, then watch part 2 of 10-2 arcs and central angles.